Hi, and welcome to my short lesson on solving equations with variables on both sides of the equal sign. Now, you watched the 18.1 supplemental, and this is just to follow up on that. I see this as a two-step equation with an additional step, maybe a three-step equation. I'm going to want the variables, well, they could be on either side of the equal sign, but I'm going to place them on the left-hand side. And I'm going to do that by using the inverse operation of adding a negative 2x to adding a positive 2x. And what that's going to do is that's going to be 0. They're going to cancel each other out. I'll just put an x here to show that they cancel each other out. And that's great. All I have is negative 29 left on the right-hand side of the equal sign. But I have to do the same thing on both sides of the equal sign to maintain this balance of equality. So I have to add 2x here. Okay, now we have 7x and 2x, that's 9x, minus 2. Okay, this is now a two-step equation. And all you'd have to do is add 2 to both sides, because that's subtracting 2. And then we divide by 9, because that's multiplying by 9. This is what it looks like. I would add 2. And I have 9x. These cancel each other out. And negative 29 plus 2, that's negative 27. So when the signs are different, you're going to subtract them. And I did. And I have more negatives and positives, so this part is going to be negative. Now that's 9 times x. I'm going to divide by 9 to get my final answer. X is going to be negative 27 divided by 9, which is negative 3. Now, what I could do is I could put, if I have 7x, so 7x, and I'm saying x is negative 3, minus 2 equals negative 2 times x, and I'm saying x is negative 3, so negative 2 times negative 3, minus 29. If I get the same number on both sides, I have the correct solution. This is negative 21 minus 2. Together, that's negative 23. And this side, this is negative times negative is positive, so that's positive 6 minus 29. And 6 minus 29 is also negative 23. So yeah, this solution checks because I get the same answer on both sides when I substitute that in for x. Okay, my last one. I am going to, once again, just like I view this as moving the variable terms to the left-hand side by using inverse operations. I'm going to do the same thing here. I see this x. I'm going to bring this x term to the other side here. And you have to put the x terms under the other x terms, or variable terms, I might say. So I would add 3x. And I have negative 15. This ends up being negative 1x equals 6, and these cancel each other out. Okay, next, I'm going to add 15 to both sides. And what this does is now these constants, which are really just terms without a variable, are canceled out. What do I have? I have negative 1x. I'm super close to knowing just what x is. And 6 plus 15 is 21. Since that's multiplication, I'm going to divide by negative 1. You have to divide by the exact same number. These cancel. And x is equal to 21 divided by 1 is 21. And positive divided by negative is negative. And there you go. To check to make sure, we would have negative 15 minus 4 times x, which is negative 21. Is that equal to 6 minus 3 times negative 21? Well, let's see. 4 times negative 21, that's 84. That's negative 84. I might see that this is negative times negative is positive. And I'm just checking to make sure that my negative 21 is the correct answer. Negative 15 plus 84. Let's see. I have to do this. I'm unable to do it in my head right now, unfortunately. That's 9. That's 7. Okay. So we have that. And then 3 times 21. That's 63. So here we have 6, and negative times negative is positive, plus 63, and we get the same number on both sides. So there you go.